All right, let's jump right in. Today, we're going to grab our digital pickaxes and head straight to the frontier of finance, because we're digging into one of the most critical, and let's be honest, most misunderstood parts of the crypto world, Bitcoin mining. So you might be thinking, gold mining, digital money, what's the connection? And it's a totally fair question. On the surface, it really sounds like we're mixing metaphors. But this idea, this comparison between digging for physical gold and creating digital money, it's not just some clever analogy. It's actually the entire foundation of how the system was designed to work from day one. You see, Bitcoin's creator, the mysterious Satoshi Nakamoto, was pretty brilliant in picking this gold mining analogy. The reason? It makes one thing crystal clear. Creating something of value takes real, honest-to-goodness effort and resources, right? You can't just snap your fingers and have gold appear, and it's the same exact principle here. You can't just create Bitcoin out of thin air. It has to be mined through a ton of computational work. Okay, so let's talk about those digital pickaxes. The tools used for this digital gold rush have evolved at a staggering pace since the early days. I'm not kidding, it's been a full-blown technological arms race. In the very beginning, and I mean way back in 2009, you could actually mine Bitcoin on a regular old home computer just using its main brain, the CPU. But that didn't last. By 2010, people figured out that GPUs, yep, those powerful graphics cards built for gaming, were way more efficient. But even that leap was short-lived. The entire game was completely turned on its head by the arrival of ASICs. These things are just monsters, custom-built, hyper-efficient machines designed to do one thing and one thing only, mine Bitcoin. And just like that, the hobbyist era was over, and the age of industrial-scale mining had begun. And here you can see the absolutely massive effect of that arms race. The network's total computing power, what we call the hash rate, has just exploded. We're now at nearly 800 exahashes per second. Now, to give you an idea of how big that number is, that's 800 quintillion guesses at the network's puzzle every single second. It's a number so huge it's almost impossible to wrap your head around, and it's precisely what makes the Bitcoin network so incredibly secure. But there's a catch. That security comes at a price. All that specialized equipment and the massive investment needed for ASICs, well, it seriously raised the barrier to entry. This isn't something you can just do in your basement for fun anymore. And this has kicked off a really big debate about centralization, with a lot of people worried that it kind of goes against Bitcoin's whole original spirit of being decentralized. So if it's not individuals tinkering in their basements, what does a modern digital mining operation actually look like today? Let's take a peek behind the curtain. For the most part, miners today join what are called mining pools. The best way to think of that is like a lottery pool at the office. Everyone throws their computing power in together to dramatically increase their odds of solving the puzzle and winning that Bitcoin reward. When they win, they just split the prize. And as you can see here, the landscape is really dominated by a few huge pools, with Foundry USA alone controlling more than a third of the entire network's hash rate. And where in the world are all these massive operations located? Well, this gives us a really clear picture. The United States has pretty much become the undisputed global leader. We're talking over 75% of the world's reported mining activity. That's largely because of states with tons of cheap energy and, frankly, a more stable regulatory environment. And just look at the drop-off after that. It really shows you how geographically concentrated this whole industry has become. Okay, let's get down to the bottom line. How does this multi-billion-dollar industry actually turn a profit? Because let me tell you, it is a game of razor-thin margins. At the end of the day, it all boils down to a really simple but often brutal equation. You've got hash price on one side, that's your revenue. Think of it as the market rate for your digital pickaxe. Then you have hash cost on the other. That's what you're spending to keep that pickaxe swinging, and it's almost all electricity. To make money, your hash price has to be higher than your hash cost. It's really that simple and that difficult. So, here is the most important takeaway right here. The single biggest factor in whether a miner succeeds or fails is their access to cheap, reliable electricity, period. It is the absolute lifeblood of this entire industry. Everything else comes second to the cost of power. And this table just lays it out perfectly. It shows you just how incredibly sensitive profits are to the price of power. So the JTH numbers, that's just a measure of how efficient the mining machine is. The lower the number, the better. Now look at a cheap electricity price of $40 per megawatt hour, pretty much everyone is making money, even older, less efficient machines. But watch what happens when you double that price to $80. Everything changes. All of a sudden, only the newest, most efficient gear can even break even. And a slightly older machine, it goes from profitable to losing money just like that. Now, you knew this was coming, right? The massive scale of this industry, its incredible thirst for power, it's obviously led to some pretty intense debates about its environmental footprint. But as you'll see, the story is a lot more complex than you might think. So, one of the biggest concerns you hear about is electronic waste. As miners are constantly upgrading to newer, better machines, what happens to the old ones? Well, the estimate for 2024 is that around 2,300 metric tons of hardware could become e-waste. To put that in perspective, that's roughly the weight of 1,500 cars. But here's where the story gets more interesting. The industry seems to be pretty actively managing this problem. As you can see from the data, over 3/4 of that retired hardware isn't just getting tossed in a landfill. It's being repurposed, sold, or donated to get a second life. And on top of that, a lot of firms are now setting up or looking into formal recycling programs. Miners are also in this really unique position to turn some environmental problems into solutions. So take natural gas flaring at oil wells. It's a huge source of methane emissions, which is terrible for the environment. But now, miners can actually set up mobile data centers right on site, capture that gas that would have just been burned off, and use it for power. It's an incredible win-win. You slash emissions, and you turn a total waste product into a valuable resource. And check this out. Here's another amazing solution. Miners are helping the power grid itself. Because these operations are basically just giant, flexible power consumers, they can act as a kind of virtual power plant. So imagine it's a crazy heat wave and everyone's blasting their AC. The grid operator can send a signal to the miners, and they can power down instantly. This frees up a huge amount of electricity for homes and businesses, helping to prevent blackouts and keep the grid stable for everyone. It's pretty cool. So where is all of this heading? Let's look to the future, because all this massive infrastructure, the data centers, the power contracts, the expertise, is finding a really surprising and powerful new purpose. And that next frontier is, of course, the absolute explosion in demand for artificial intelligence. It turns out that the exact same infrastructure that was built to mine Bitcoin, these huge data centers with access to massive amounts of power, is perfectly suited for the incredibly intense computing needs of AI and what's known as high-performance computing. And this chart, wow, this chart tells you everything you need to know about why this pivot is happening. The economic incentive here is just staggering. Look at the revenue miners can earn by providing AI computing services. It absolutely dwarfs what they can make from Bitcoin mining. For the same exact amount of power, we're talking about a potential revenue increase of more than 20 times. It's a no-brainer. And this brings the entire industry to this really fascinating crossroads. It all started as a way to create and secure a new form of money, a kind of digital gold. But in the process of building all that out, it might have accidentally built the perfect foundation for the next huge wave in technology. So the big question is the future of this industry really about mining digital gold, or is it about becoming the backbone that powers our entire AI-driven world? That's the question that's going to define its next chapter.